Hi everyone, this is Mrs. Jackson. This is Chapter 2, Section 6, Part 2, and in this video we are going to practice the quadratic formula. So in the last video we derived the quadratic formula, and here we're going to see how to use it, as well as learn about a new vocab term called the discriminant, and how you can use that in a way to find out how many real solutions there are, or if you have complex solutions. It's a quick and easy way to test for the type of solutions. Okay, let's get started. First thing I should mention is I did not leave very much room up here on the top to do these two examples. So I would recommend writing small. Okay, let's go. So each quadratic equation that you're trying to solve, if you want to use the quadratic formula, you need to put that quadratic equation in standard form. And standard form is ax squared plus bx plus c equals 0. So quick reminder, a is just the coefficient in front of the x squared term, b is the coefficient in front of the x term, and c is the pure constant. You want 0 over here on the right hand side, so everything has to be moved over. All right, and so here on example number 1, if I want to move that 4x over, I'm going to subtract 4x from both sides. I'm not going to show all of the inverse operations in interest of space here. So if I subtract 4x from both sides, the 4x becomes negative on the left, and if I add 9 to both sides, the 9 becomes positive, and I have 0 on the right hand side. Okay, to use the quadratic formula, we're going to identify a, b, and c. So a equals, in this case, 1. Our b equals -4. And our c equals +9. The quadratic formula that we derived in the last video says that x equals the opposite of b, or -b, plus or minus the square root of b squared minus 4ac all over 2a. So we're going to simply just substitute in this a over here in my formula. It doesn't look like an a. We're just going to substitute our numbers right into the formula. So x equals the opposite of b. The opposite of -4 is +4, plus or minus the square root of b squared, so that becomes 16, minus 4a, that's a 1, times c is 9, all over 2 times a, which is 2 times 1, or just 2. X equals +4 plus or minus the square root of 16 minus 36, all over 2. X equals +4 plus or minus 16 minus 36 is -20, all over 2. Hopefully you are seeing that we're going to expect complex solutions here. X equals +4 plus or minus square root of 20, or -20, that's 4 times 5. So I'm going to write that as the square root of 4 times 5. When I take the square root of that -1 in there, I have I coming out, imaginary unit, all over 2. And finally, if I simplify this, the square root of 4 right here, our perfect square, I'm going to take that out, and that is going to become 2. So I have 4 plus or minus 2 square roots of 5, I. Notice the I is not underneath the radical, all over 2. And I can actually go ahead and divide both the terms in the numerator by 2, since they're both even. So x equals 4 divided by 2 would be 2, plus or minus 2 square roots of 5 divided by 2 would just leave us square root of 5, I. So what we have left here is 2 complex conjugate solutions, 2 plus or minus the square root of 5i. Okay, let's take a look at one more example here. 4x squared minus 22 equals 12x. We need to get that into standard form. Again, I'm not going to show those inverse operations, but if we subtract 12x from both sides, that 12x becomes minus 12x on the left, minus 22, and then we have 0 on the right, which is what we want. Now, every single number, every single coefficient here and the constant are all even numbers, so you can always simplify your numbers here, your math, by dividing that out. We could take that 2 out, essentially by dividing everything by 2, and what we would have left is 2x squared minus 6x minus 11 equals 0. Now I want to just quick remind you that by factoring out that 2, this, if we graphed this function and this function, they would not be identical. I did change the function by dividing out by 2. I essentially lowered the stretch. However, they both have exactly the same x-intercepts, and that's what we're focused on right now by solving this quadratic equation. So by dividing through by 2, I have not changed those x-intercepts. Okay, now let's just identify our a, b, and c. We've got a equals 2, b equals negative 6, and c equals negative 11. And we're going to substitute that right into the formula. So I have x equals the opposite of b. The opposite of negative 6 is positive 6, plus or minus the square root of b squared. Negative 6 squared is positive 36, minus 4ac, all over, and this c is negative, all over 2 times a, which is 2 times 2. X equals positive 6 plus or minus the square root of 36, and I have here a negative times a negative, so we've got 44 times 2, which is 88, so that's going to turn positive 88 all over 4. I have x equals 6 plus or minus the square root of, what do we got here, 124 all over 4. X equals 6 plus or minus. Let's see if we can break 124 down. That would be 4 times 31. So inside that radical, we've got 4 times 31 all over 4. So we have x equals 6 plus or minus. We're going to take the square root of 4 out. The square root of 4 is 2. So we've got 2 square roots of 31 all over 4. And we might as well keep going. Each of these terms are evenly divisible by 2, everything there. So we can further simplify that down to x equals 3 plus or minus the square root of 31 all over 2. And so what we're left here are real conjugates. The square root of 31 is irrational, but it is a real number. So this particular function, if graphed, would cross through the x-axis in 2 different places, and our solutions are real conjugates. Okay, let's introduce one last concept here, and it's called the discriminant. So the discriminant is a new vocab word that you're going to need to know. The discriminant is something I always confuse with the determinant. That's something else in math. The discriminant is the radicand portion of the quadratic formula, and it can be used to determine how many real solutions or even what type of solutions you have. So the discriminant is the radicand portion, and by that I mean what's underneath the radical. So the discriminant is going to be b squared minus 4ac. What is underneath that radical in that formula? Okay, so let's take a look at case 1 here. So I'm going to describe case 1 as a discriminant, and I'm going to use a capital D for discriminant, is positive. In other words, D is greater than 0, B squared minus 4AC is greater than 0, is positive. So if that discriminant is positive, we are going to have two real solutions. In other words, two x-intercepts that go right through that x-axis. Graphically, that's going to look, either an upward facing U or a downward facing U, but ultimately it's going to have two x-intercepts here going through that real number line, which is what the x-axis is. Okay, the next scenario would be if the discriminant equals 0. So if D exactly equals 0, or B squared minus 4AC equals 0, then we don't have anything to plus or minus in that formula. So in that case, we're going to have one real solution. There's only one way to have one real solution, and that is if the vertex is sitting right on the axis. So it could be upward facing or downward facing, but the vertex is right on the real number line. And the last scenario would be if the discriminant is negative or less than 0. So if D is less than 0, if B squared minus 4AC is less than 0, and I'll just put over here negative, then we are not going to have any real solutions. So there's no real solutions, because if we take the square root of a negative number, we're going to end up with imaginary. So no real solutions, and maybe just in a different color here, we'll say two complex conjugates. And so we've already looked at that in the past. That could be, for example, some kind of parabola that's never going to intersect the real number line, the x-axis. All right, so let's just maybe in our notes, we'll just put a quick little D is positive. D equals 0 here, and D is negative. All right, in this video, we practice using the quadratic formula. And in our two examples, we had complex conjugates as well as real conjugates. But by the way, you could use the quadratic formula and get integers as solutions. That would have been a quadratic equation that was factorable. But if you don't want to factor anymore, you could always use the quadratic formula to solve for any type of solution. And then the other thing we learned about in this video is what the discriminant is and how you can use it very quickly to figure out what type and how many solutions you have. All right, I hope this helps. Thanks for listening.